I had a follower ask me to draw him a control sequence, and I have it drawn out right here. Let's go and take a look at the sequence that he's looking for first before we come back and interpret this.
So this was the sequence that he was asking for. It's too long, I won't read it. If you want to read it, just pause it and go ahead and read it.
Coming back to this is just the control circuit. There is no power circuit. This is just the control side. He didn't specify what kind of control voltage, but I just added in 24 volts DC because that is a good control voltage to use. So coming off, we have a stop, a start, a latching circuit from our MCR, our master control relay coil. We are using a set of normally open contacts here to latch itself in, and we have our master control relay. We also have another set of normally open contacts from our master control relay on this rung, and we have a photocell. We have a normally open set of contact from our motor starter, a normally closed, time, open set of contact from our on delay timer. We have our motor starter coil. We also are using a set of normally open auxiliary contact from our motor starter coil. On this rung, that's going to turn on a green indicating light for when the conveyor is moving product down the line. So bringing in 24 volts, we have wire number 1 coming to our stop, and then terminating out from our stop, and then parallels out to our start button, and also to one side of our normally open set of contacts from our MCR coil. Once we hit start, push the start button down, it's going to send 24 volts over to MCR, our coil. Our coil is going to then energize. This is our return wire, wire number 2, back to our negative power source. Coil energizes, and instantly it's going to close this set of normally open contacts, which then is going to provide 24 volts over to wire number 4, and that is how this master control relay is going to maintain energized.
And then as soon as this MCR coil energizes, it closes that normally open contact. It also closes this normally open contact. It's going to bring in 24 volts to a photocell eye, and it's going to parallel down over to a normally open set of auxiliary contacts from our motor starter coil. At this point, it's going to be the photocell that's going to switch and close to allow power to get over to our motor starter coil and to energize our on delay timer coil. So as when the photocell sees that product's on the conveyor, it's then going to switch. It's going to close. It's going to switch over the 24 volts over to our motor starter coil to the A1 side. It's also going to parallel down to the A1 side of our on delay timer. Our motor starter coil, as long as the overload is not tripped, is going to complete this path. It's going to energize. The on delay timer is also going to complete its path through wire number 2 back to our return side of our power source. It's going to energize. At this moment, the auxiliary contacts on this rung and this rung is then going to close. So this set of normally open contact closes. It's going to bring the 24 volts over to this set of normally closed, timed on set of contact from our time delay timer. Now this is normally closed, but this timer needs to have this 24 volts present for the set amount of time that you set it to. So let's say that it is set to 5 minutes. So this coil must maintain energized for 5 minutes before this set of contact can break open. So the moment this motor starter coil energizes, this closes. This is going to bring 24 volts through here. And this memory rung right here is what's going to keep our motor starter coil energized and our timer energized. After 5 minutes elapse, this is going to then break open. The timer will then break open, and it will cut off continuity or electrical flow to our motor starter coil and our timer on delay timer coil. It's then going to stop the conveyor. while the motor starter coil is energized, it is also going to close this set of normally open contact, auxiliary contact on the motor starter, which is then going to bring in 24 volts to our green indicating light. And that is how operators will know that the conveyor is running and there's product on the conveyor, because if the motor starter is engaged and the conveyor belt is running, that light is also on. Once this normally closed contact on our time delay opens and breaks power over to our motor starter coil and the timer, it then stops the conveyor flow. So the conveyor stops working, and then the photocell needs to see product again. The photocell is only on for a brief momentarily time. So when the product comes, photocell sees it, it triggers that 24 volt output to our motor starter, conveyor starts, this latches in, this photocell opens back up. Once the product passes the photocell and it no longer sees product, that opens back up. And electricity takes this route over to the motor starter coil and the timer. Photocell sees the next product come up, and then triggers the motor starter and the timer on delay to repeat the process over again. If the operator would want to stop the cycle any given time, he or she can just hit the stop, and it will cut power to our MCR, which then cuts power from this normally open set of contacts. This will open back up, and then it will cut power to everything downstream. So I hope this is the correct sequence that you're looking for. Until next time, deuces.